Hey everyone, Nishant here. Today we'll be going over question number 1 in exam prep discussion 6. For this question, we have a lot of Java code written out here. And what the question is asking us to do is look through all the code and see which lines would result in some sort of error, either during compilation or execution. And then for each of those crossed out lines, we should write a replacement line so we can fix this error. Based on like what intent we think this line would have had. We don't want to change as like too many lines. We just want to change exactly the lines that we think are problematic. And then, yeah, once we do that, we can figure out what would be printed from running one of these classes, p2.c5. Yeah, let's jump into this. So the first thing that I think is good to do is to look at the entire class structure and understand what type of polymorphism is happening. And then once we figure out sort of the relationship between all the classes and whatever is going on here, it should make it a little bit easier to figure out which lines are going wrong. So I've created a little bit of a dependency, I guess, like between the classes and the different packages, but so that I don't have to write it later, but we're just gonna go through everything one more time. So notice that we're declaring these classes in packages. So we have package P1, and package P1 has class C1, class C2, which is a subclass of class C1. So I'm indicating with this arrow here. Then we have class C3, and those are the three classes that are in package 1 or P1. There's also that C3 extends C2, so we've indicated that over here. Okay, finally, we have package P2, and this has two classes where C4 is extending C2, and we have C5 just standalone its own class. So we have that reflected here. We see that C4 extends C2 and C5 is by itself. So that's kind of nice for us to know, something to think about. Okay, let's go through this and line by line, make sure that we're not going to run into any errors. If we are running into errors, let's fix those. Okay, so looking at this first section here, we have private integer a equals 1, protected integer b equals 2, and integer c equals 3. No problems there. We have a perfectly good return or function here that returns 13. And then we have 3 setter methods, 3 getter methods. These types are public, but they're just setting variables inside the class a to v, b to v, c to v, and we're returning those types. And then we have a toString method. toString method overrides the object class's toString, and when we call print on this object, we will be getting, this sort of output, which will then be printed. So that's like turning it to string, and that will be printed. And that's what we're using it for in this problem, but you can also just call .toString on this class, and then you will get a string that looks like this. Okay. Now, so far, it looks like there aren't any problems just with the code that we've seen, but we're going to keep going. We have a package C1 or P1 with a class C2 that extends C1. So first we have this one constructor that doesn't take any arguments, doesn't do anything. And that's fine. That's basically not doing anything, and that's good to go. Now we have this other constructor, which takes in A, B, and C as arguments, and then we're saying this dot A equals A, this dot B equals B, this dot C equals C. Okay. It's because we haven't declared any other variables. These variables that we're setting here are the same ones that are inherited from this class, C1. because they're inherited from C1, we need to think about what protection they've been given. And with the C and B, the protection allows C2 to still access these variables, but notice that A equals 1 is actually private to class C1. And that means that even a sub or a subtype of C1 cannot access this variable. So in that case, we need to do something about this line, otherwise we will have an error. So what we will do instead is that we will use this setter method provided on line 10 and say, hey, we'll set A, pass in A, and then we'll be able to avoid an error because we're letting this setter method actually set this variable and not actually accessing it ourselves. Okay, let's keep going. So what else do we have here? We have a method D, and D is just overriding the other D method that was in C1, and that's allowed as we're a subtype. And then 34, we're returning a type C1 from gen, and we're returning this as a new C3. Let's just make sure that works. And notice that C3 is a subtype of C2, which is a subtype of C1, and that's okay. A good analogy here would be, hey, if we have animal and we have a subtype bird and we have a subtype falcon, a falcon is still a bird and a falcon is still an animal. We can't say an animal is always a falcon, but we can say a falcon is an animal. So this method makes sense. This chart is going to become useful soon. Didn't mean to reveal it right now. Okay, let's keep going. So now we have finally class C3, and class C3 is extending C2. So that's fine. But now we should look at what's going on inside the function. Here we have a equals 15. We have a string method that overrides like whatever string method was there already, and it uses this string method. Yeah, so everything looks fine there. Let's move on to class C4. Okay, so there are a couple of things we should notice here. First, class C4 extends C2. C2 is actually not in the package that C4 is in, right? So C2 is in package P1 and C4 is actually in package P2. So we can't actually extend this class because we have no access to it because we haven't imported the package. So what we can do is, assuming that they're both in the same directory, we say that C4 extends P1.C2. In this way, we'll still be accessing P1. Another thing that should have caught our eye before is that C2 is being accessed by C4, but we haven't had any access modifier to C2. This means C4 actually cannot access C2. So we're going to have to make this a public class. So now with these changes, we're finally able to fix whatever's happening in this line. Before that, we would have just had access issue, and that would have led to an error because we couldn't access package P1, then so we couldn't import C2, and then C2 wasn't public, so we can access that. Now we can continue with looking at this code. So for get B, this looks fine. we're just using the B inherited from the subclass or from the superclass, or we're using these B's rather, whatever is being set here and here. Okay, let's look at this first constructor. So the first constructor takes in 3 different integers, and we're going to set A equal to A, B equal to B, and C equals to C. The first thing that should pop out is this line. Remember that back in C2, we weren't allowed to do this. We weren't allowed to set A equal to A because we couldn't access this private integer. So similarly, we need to keep using set A, and that will do the job for us. Okay, for B, B is a protected integer. This means that if it's protected, we can access it in a different package, subclass, same package, non-subclass, same package, subclass, and same class, but not if a different package, non-subclass. Because C4 is a subclass of C2 and C2 is a subclass of C1, we are allowed to do this under the definition of what a protected variable is. Finally, we have this dot C equals C, right? And what that is just a default declaration of this variable. With the default declaration, we consider that package private. And for package private, we actually cannot access from outside the package. We can only do accesses from inside the package. Lucky for us, we have a handy dandy setter method, so we can just set C to C. Okay, let's look at line 60. On line 60, we see something very similar, right? We're still trying to set A and C equal to V. This time it's just one variable. The problem here, again, is the same as we had before. We're doing we have these problematic like accesses to A and C. So what can we do? We need to like replace this in one line. So let's try to draw inspiration from maybe setter method, something else. We can't really use a setter method because we need to do it in one line. But notice that we have a constructor for C2 that sets all the variables, right? So C1 doesn't set all the variables, but C2 does in some way set all the variables. So we can call the superclasses constructor and simply pass in V for every single one, and they'll all be set to V. So that's how we've been able to circumvent, I guess, that problem. Okay. Finally, we have class C5. We're almost at the end. So for class C5, we have this first set, and notice that we're running into the same problem that we ran into on line 50, right? We don't have this package imported. So what ends up happening is that we can access C1, C3, and C2. So we're going to cross out these lines and rewrite them so that we can have P1.C1 equals new P1.C1, P1.C2, Y equals new C4, 20, 30, 40, and C3 Z, P1.C3Z equals Y dot gen. Excuse me. Another thing we should have noticed, again, is now we're accessing C1, we're accessing C3. These are from different packages, but let's check their access modifiers and see how C3 is not a public class. So we need to fix this so that we don't have an error. And C1 also doesn't have an access modifier. So we need to fix that as well. So now we made our classes public. We have used, like, prefaced the class that we're using from the package using p1.c1. Now let's actually see if these lines make sense. So we're saying c1 equals a new c1 object. It's all imported. This should be fine. Then for this next piece, we're saying c2 type c2 y is equal to a new c4 object. And remember what we were saying about subtypes, that we're actually allowed to do this declaration because c4 is of type c2. This is as a subtype, but we couldn't do something like c4 y equals new c2. I forget what the constructor is, but right, whatever that constructor would be, this is not allowed. Okay, finally we have reiterating that this is fine. We also have this piece here with p1.c3 z equals y.gen. So let's check out what y.gen is doing, make sure that everything works out there. So y.gen is this gen method from C2, and this is returning something of type C1. And here we see we have a problem because we've declared z to be type C3, so that's a static type, and now we're trying to assign it to something of type C1. That leads to a compilation error. And in order to fix this, what can we do? If we look back here, actually, we notice that we're actually returning this new C3 object, and it's being returned as a type C1, which we have said is okay because it's a subtype. But what that means is we can just cast this, whatever is returned here by y.gen, as a type C3. Okay. So once we cast this and fix that error, looks like our code should compile and run correctly. So if it compiles and runs correctly, we can then check out what's going on with these print statements. So for these print statements, let's first look at x, right? We're saying, let's print x. X is just a new C1. C1 didn't have a constructor, but we can use the toString method. And we notice that all these variables are still already declared, and we can start. So we have a space with a get b, which is 2, space get c, 3, and then d, which will return 13. So that's for the first print statement. Now for the next print statement, we're casting y as a type C2, and then printing that. So first thing first, we should look at C4, and C4 is constructed with 20, 30, and 40, right? So this is setting a 20, B to 30, and C to 40. We're inheriting like the toString method from package C1. But then what's going to happen is we have this get b method, and get b is returning 2 times b, right? So if we print first 20, which was a, and we try to print, we say get b actually overrode this method, and we're returning 2 times b. 2 times b is 30 times 2, which is 60. And then we want to get c, which was 40. Okay, so what's happening to d, right? D is a static method in both C2 and for C1. And because this method is static, this is decided at compile time. You can't override a static method in C1, right? So despite like inheriting or being the subtype of C1 or of C2. C4 is still using the toString method here, and we're going to use the D that exists in C1, and that will return us 13. So the final values printed will be 20, 60 because we're using the getB method from C4, and 40, which was set, and 13 because we can't override the static method D. Okay. Finally, we have printing of Z. So Z was YGen, and YGen is returning a C3 type. This leaves us with 15 as A, and then a toString method, which has overridden this toString method from C1. Okay. Even though we didn't declare B, C, and D, or not D, but B and C, we can still use the ones that were declared in C1, as that is a superclass. So we will say 15, 2, 3. And now what would we return for D? Because D, we overrode the toString method, we're using the toString method here in C3. This means that we actually use the D from C2 because this is the class we're directly inheriting. In that case, we'll actually be returning 14 instead of 13. That's because we didn't use the toString method in C1, which would have made us use this method. We're actually just using the toString method in C3, and that allows us to use C2's D, right? We're inheriting that from C2 rather than from C1. So this is the final output after we've made all the code changes. So yeah.